Up to this point, we have been treating every object as a point object and studying the motion of that point. Now, in general, this will not be a valid description unless that point is a special point. So if you consider the general motion of an arbitrary system, it can make a translational motion. So if the object is not rotating and not doing any other kind of motion, like the motion of this pen now, then we can just take any point on this mass as our reference point, and all the other points will be basically following the same trajectory anyway. So in this case, our description will be valid. Now, if the object is rotating like this, as it is translating, in that case, if you study the motion of, let's say, the tip will be making a complicated motion. So this complicated motion, such a complicated motion, this will be the motion of the tip. Such a complicated motion is, well, we will eventually be treating these motions, but this is definitely not the projectile motion that we have been studying. But still, even in this case, there is a special point on this pen. So even if we throw it, as it is rotating and carrying out projectile motion, the tip will be following such a trajectory, but there is a special point which will follow this parabolic trajectory, the trajectory of the projectile motion. And this special point is what is called the center of mass of the object. Now we will see that in these few future videos that the center of mass can actually be treated as if to represent the whole of the object. Now, of course, the general motion of the object will be a much complicated motion. It can be rotating, or if it is elastic, it can also be vibrating around the center of mass. So we will be splitting the motion, the general motion of an object, as the motion of the center of mass plus the rotational motion around the center of mass plus the vibrational motion around the center of mass, etc. Now, the definition of this center of mass is, if we start from a simple example of two objects on the x-axis. So this is the mass A, this is the mass B. For such a system, the position of the center of mass is defined as the weighted average of the positions of those two masses. You just take the mass, multiply by the position of that mass, and add this product for all the masses. In this case, we have just two, and divide by the total mass. So this tells us what the center of mass, where the center of mass is. Now, in this case, the center of mass will be somewhere in between these two masses. If the two masses are equal, if MA and MB, they are equal, the center of mass will be right at the center. If one of the masses is heavier, let's say if MB is heavier than MA, the center of mass will be closer to the heavier mass. If the mass of one object can be completely ignored, if let's say the mass of A is negligible compared to mass of B, so if we neglect these terms, the center of mass is at the position of this very heavy object. Now, if in the problem we have more than one particle, this can be generalized. The position of the center of mass for more than two objects will be just, for each one of the masses, multiply their mass with their position, sum over all these masses, all these particles, and divide by the total mass, where the total mass is just the sum of all the masses. So this is the position of the center of mass for a system containing more than two particles. Now, if the system moves in 2 or 3 dimensions, we can define the corresponding component, x, y, and z components, in a similar fashion. Y center of mass will be just I times multiply the mass of each particle with the y position, y coordinate of that particle, divide by the total mass, and the z coordinate of the center of mass is take each one of the particles, multiply the mass of that particle with the z component of their position, divide by the total mass. Now, all of these equations can be written in a vectorial form. The position of the center of mass is defined as the mass multiplied by the position vector of the ith mass divided by the total mass. Now, of course, the coordinates, x, y, and z coordinates will depend on how you choose the how you choose your axis, where you put the origin. But although they change, the physical point of the center of mass will always corresponding to the same point.